Okay, so that's one example. Let's do another one then. Oh, sorry. Wrong button. Here we go. Here we go. So here's another example. So here we have minus x squared plus 6 times x minus 3. As you can see, we have that. And now right away you can see what A, B, and C are. Right? We have A is negative 1. We have B is 6. We have C is minus 3. So we're getting A, B, and C, right? I mean, I know I didn't really write out the steps, but you can see there is some kind of procedure here, or algorithm, so to say. So first we're getting A, B, and C. Then we get the vertex. Right? For the vertex, we have negative B over 2 times A, right? We have to calculate that. That's actually pretty easy because we know what B and A are. So we have negative 6 over 2 times negative 1. Right? Negative, negative, we get 6 over 2. It becomes a positive, so we have 6 over 2, which is 3. And so from there, f of minus b over 2a. Remember, we're using, let me go back to the formula. I remember we're getting this formula here. This is the vertex. Okay? You know, with this formula, we don't have to worry about completing the square. You know, if for some reason we didn't know the formula, then we would have to complete the square. We don't have to, thank goodness. It's not terrible, it's just, you know, it's a little involved. Actually, how they prove the quadratic formula, the method of completing the square. So we have f of minus b over 2a, right? That's equal to f of 3 in this case. So we're replacing x by 3, we're calculating, and doing so, it looks like we get 6. So we have our vertex, right? It's that point. We have the axis of symmetry, right? That's x equal, that's what we got up here. I mean, this number we had to calculate either way. We had to get it for the axis of symmetry, and it's the x coordinate of the vertex. And the y-intercept, you know, if you just replace x by 0, you get minus 3. It's also just a constant term, mostly because if you replace x by 0, these terms are gone. So you don't have to memorize what to calculate. I will tell you what to calculate on exams, quizzes, and that stuff. Okay, so we have this. Now we need the x-intercepts, right? So again, quadratic formula. We have minus b, right? Plus or minus the square root of b squared over minus 4ac over 2a. Right, so we have our a, b, and c. So I'm just replacing. So I replace b with 6 in the formula, a also with minus 1, c with minus 3. We have all this, as you can see. So from here, what we're going to get is minus 6 plus or minus 6 squared is 36 minus 4 times minus 1 times minus 3. Well, this is equal to 12. So we have 36 minus 12 over minus 2. That's equal to this. And again, I just used the calculator to get the decimal form. All I did. Mostly because the square root of 24 is not a perfect square. So the square root of 24 is not, how do I say it? It's not a nice number, so to say. Well, it's not terrible. Now that we know the x-intercepts, we have everything we need. Notice since a is negative, I forgot to point that out. Oh, wait, no, there we go. Since a is negative, that's how we knew beforehand the graph is going to open downward, like so. This is the vertex, right? -3, that's where it crosses the y-axis. The y-intercept, here are the x-intercepts, as you can see. Okay. The axis of symmetry, again, I didn't graph it, but I guess that's okay. So. And again, also for the range, right? We can see that 6 is in the range. And we can see, hopefully, even without drawing those lines, I hope you can see that visually, everything below 6, including 6, is in the range. Mostly because if you did draw a horizontal line, you can kind of see it from the grids here, every number below 6 is also in the range. So that's why this is the range. What the heck, let me draw it. Let me draw the axis symmetry as well. Oh my goodness gracious. One day I'll be able to draw straight line segments. We're doing this, as you can see. And again, that's the axis of symmetry. Hopefully you can see that the graph is symmetric about it. And for the range, just to help illustrate it, if you draw horizontal lines for the graph, you can see that every number, including 6 and below, every number from 6 and below is in the range. But mostly because if you can draw a horizontal line from the graph to that number. Well, you can keep on doing this, and eventually you'll get all this.
How did you get the range again?
Oh, if you can draw horizontal lines like I'm trying to draw here. Hold on, let me get the laser thing. You can draw these horizontal lines, and what you're doing is you're drawing it to the y-axis. And any number on the y-axis that the horizontal line intercepts is in the range. Does that help? Or it's kind of like, that's just how you do it. It takes a little visualization. What's really happening is you can draw these horizontal lines, and you're projecting the graph horizontally to the y-axis.
So there's no way to find the range without a graph?
You can. I'm just showing you that you don't have to. I mean, you can actually get the range. Since A is negative and the vertex is 6 in this case, that tells you the range is going to be from -infinity to 6.
Okay, thank you.
Let me show. Actually, if we go back to a previous slide, I think I wrote it. I hope I wrote it down. Let me see. Here we go. Down here. If A is positive, then the range will go from the y-coordinate of the vertex to infinity. And if it's negative, it's going to go from the, what do you call it? It's going to go from the vertex, the y-coordinate, down to -infinity. I don't know if that helps or not. I hope it does.
Yeah, thank you.
You're welcome. I mean, but even without a graph, you can get the range. I was just trying to show you, it does take a little visualization how to get the range. So I'm basically doing that same method from 2.4. I think it's a lot easier if I'm physically in class, but doing what I can here. So, all right. Wait, is this? Oh no, we didn't do that one yet. Did we? Oh, yeah. Okay, similar, but okay. All right. Wasn't. Oh, good. I'm glad someone asked that though. So good question. Although the wording could have been better in what I wrote on the slide, because it's from -infinity to the y-coordinate. So just letting you know. Any other questions? Okay. And here's another one. I figured I'd go through this one as well. And then hopefully I'll be able to let you guys try one on your own. Worst case is we do that on Friday. Let me go through this one. So same idea, right? So here we have x squared, right, minus 2x plus 3. So we have a is now positive, it's 1, right? We know that b is minus 2, c is 3. So it's just like before, right? We have to calculate negative b over 2 times a. That's what I'm doing here. We have minus, we have b, which is negative 2. Numbers are off. So we have that. Wait, I make a mistake? Yeah, you know what? Forget this one. Oh, I know what. I know. This is the one I wanted you guys to do. That's what it was. My mistake. Okay. Yeah. Okay, here. This is actually the one I wanted you guys to do. But let's do this one together. So we have a here.